Good afternoon, everybody. So, a few household items first, or at least one. I want you to know that I am perfectly aware that I will be in between you and drinks at the end of this talk. But please, I want you to realize that there is some live coding involved in this talk. And I did not make the schedule, so I did not put the live coding slot in front of the drinks. So we're going to need each other on this one. And if you see me make a mistake, and you will, or at least I will make mistakes, and hopefully some of you will see it, please don't just wait and for me to figure out what went wrong. All right, so who of you has heard of CQRS before? Well, that's good. That's more than the 2 hands I got a couple of years ago on talks about the similar subject. Who of you is using CQRS? Oh, wow, that's even more than a couple of weeks ago. Who of you is not aware that they're actually using CQRS? Oh, that's maybe that was a trick question. All right. So, I want to make a confession, right? I have built horrible, obnoxious systems in my career. And I especially apologize to all those people that are currently maintaining those systems. If any of you are in the room, please step forward and I'll get you a beer afterwards. Of course, I'm Dutch, so the beer is free here, so I'll gladly give you a free beer. So, as most of us, I guess, I've been using an architectural style called layered architecture. Why? Because, well, that's what I was taught, and that was what my colleagues confirmed in the beginning. And in this layered architecture, there's this interesting thing on the right called the domain model. Now, we called it a domain model, but in retrospect, it wasn't really a domain model. It was just entities mapped to a Java class. And let's look at what happened. So we had this nice domain model, and it doesn't really matter what kind of project it was. And then you have this service layer sitting on top of it. And especially in the beginning, I was involved in a lot of these greenfield projects. They're wonderful because you don't have any problems. You just create a few problems for somebody else to maintain. I already apologized, so I'm not doing that again. And in the beginning, all these services, they map really nicely to some of these entities in your domain model. If this sounds familiar to you, I hope this sounds familiar, that this is really nice. This is what I love about greenfield projects. And you know, the second service will probably also match. So this might be an inventory service that maps to the inventory entity, and there's this product service, and that's all nice because that keeps your queries really simple. You just go to for example, a Spring repository and just say, well, give me that item and manipulate it and do whatever you want and store it back. And then there's always this one sprint where there's this one story that messes up the entire idea of your domain model. And there is this service that needs to know a bit about everything. Sometimes these are reporting services. Right? They need to combine everything. How does this work compared to that? Well, let's do a gigantic query. And unfortunately, this leads to some queries that we end up calling normal. Now, do realize when you're laughing at the original author. This is an actual query that somebody gave me. I was using another one, which I found in one of my old projects, and somebody said, well, I've got a real query for you. I just had to promise it was illegible. And this is quite an old query, and at the time, projectors, they didn't have this high resolution, so it was not a problem. And that resolution increases, and people were able to read it. And then I thought, okay, that's going to be a problem because I promised that you could not read it. So I went to my screen and started reading the query. Trust me, even if you can read each individual character, you cannot read this query. And that was the entire problem, right? The query is completely unmaintainable. So this particular one, I did the count here, has 22 joins and 6 subqueries. This is a write-only query. A developer can write it. If you're up there maintaining it, good luck. It's probably a day job. So what do we do when we have this type of queries? Well, it doesn't perform, so we smack whatever kind of optimization that we can find on the web on our architecture. And mainly what we do is we add some caches. We need to scale out a session replication. I don't hear that much about it anymore, which I think is a good thing. There's a lot of caches, right? Spring helps you. You just put some annotations on methods, and suddenly they're cached. Problems gone, right? A cache is a very bad solution to problems. It's just a very good optimization of something that works really well. But there's something else that struck me, and of course this is only, it's partially exaggerating, but the problem that we have is actually in the domain model. And look at where we are putting all of our solutions. They're all over the place, except in the one place where the problem really is. And when you ask developers, what were you building? What is it that you had in mind when you started building this stuff? And they says, yeah, we wanted this performant application, and basically describing something like this. Of course, this is not the fastest car out there, whatever, but I think we can agree that this car has a decent performance, probably. At least the picture is taken in a way that makes us believe so. But in reality, when you look at code, and sometimes it's hard when you look at your own code to see this, but try, right? Take a few steps back. Try to look at yourself behind your computer and see what you're looking at, and you might see this. And this, of course, has all the exact same characteristics as the car before, right? It has a spoiler, it has a side skirt, but why doesn't it perform? Well, I wonder, really. If this is your car, I, again, apologize for making fun of it. I'm pretty sure you had a lot of fun building it. So in software, fortunately there's a term for all of this, and it's called the big ball of mud. And here's some news for you. It's not mud. And on this particular big ball of mud, like with any big ball of mud out there, there is an architect proudly protecting its creation. If you are that architect, okay, sorry. Well. I heard some people pointing at, did I see some people pointing at each other? Hey, that's you? No? Anyone recognize himself in this picture? No. All right. So personally, I don't mind making mistakes. I don't mind making big balls of mud. I was that architect on top of there, and I tried to improve my life. But I didn't really know what was wrong. And at the time, I worked for a consulting company, and we don't really mind doing things wrong, right? Because, well, you can charge by the hour, so... I did not say that on the record. But I don't mind making mistakes, but what I do mind is making the same mistake twice, right? If you make a mistake, that means you've had a learning experience. If you make the same mistake again, it means you've missed the learning experience. And that's pretty stupid. So I thought, okay, what I'm doing is really stupid, and I need to investigate what's going on. And the way we did that is we write some code, we write an experiment, and we put it on GitHub, or at the time, Google Code. And, well, if you do that, you need a name for this. And Axon Framework was not the name at the time. And so I did an experiment, and I got this email from a company a couple months later, and they said, "We are using your framework in production." I was like, oh, whoa, time out. Well, that's 2 items of news in a very short sentence. Apparently, I've been creating a framework. Didn't know. And why the hell do you want to use that in production? But you know, there's production and there's production. There's like, oh, we've got this Excel sheet and now 2 people need to work on it, so let's put something in production. So I asked, okay, what are you using it for? Well, it's an application that traces tools used in dental surgery. Whoa. Okay, so you mean physically putting stuff in people? And yes, okay. And as far as I know, nobody has died because of an application running on Axon. So this was about 8 years ago. And fortunately, Axon has evolved, so nowadays it's safe to use it for applications, even if you use the application to poke stuff in people. We are at version 3.2 at the moment. And Axon is originally started off as a CQRS framework for Java, for the JVM. And for those not familiar with CQRS, I know a lot of people raise their hands, but CQRS is a very simple architectural pattern that basically says, split your commands and your queries. In other words, divide your application into different components where you distinguish between those components dealing with commands, which are changes to your system or requests to change the application state, versus the queries, which are questions about the current state. So have other components deal with providing information about the application state. And if you do that, it allows you to create different models for these different parts as well. So in your command model, you can fully focus on the actual behavior of your application, on validation of commands. Whereas in the projections, you can focus on what is the most efficient way, whatever efficient means in your particular use case, to expose this information. And whatever is the best way to actually store it. It might be a relational database, might be a search engine, might be a graph database, whatever you need to efficiently provide that information. And in practice, although it's not pure CQRS anymore, this is already a CQRS-based architecture. In practice, we use events to communicate any changes that happen in the command model to the other models out there. Right. So having these different models allows us to have a look at these non-functionals that we have in our application and treat them differently on either side of the application. So some of our models might be optimized for a lot of modifications that need to be really fast, whereas other components might not be changed as fast and as often, which is fine. And the same for the query model. Now, if we do this, we are emitting these events, and these events are actually very valuable pieces of information. These events are the purest form of describing what's happening in your application. And there's a lot of hidden value in these events. And especially with architectural styles like CQRS, event sourcing has making a big rise. So who of you is using event sourcing at the moment? Well, that's a pretty decent amount. Now, I know of some companies running on Axon that have an event store at the moment with billions of events. They are scared by the mere idea of not having an event stored because there's value. And why the hell would you throw that value away? The cost of storage is nothing compared to the value of these events for them, right? So you can use event sourcing, and what that does is the following. So imagine an order, and if we use state storage, I don't really know what to call it. You just store the current state, and every update basically deletes the old state. And as you know, delete means removing information. So in our order, what we can see is that there's an order for one chair, and the status is that the return shipment has been received. In other words, somebody bought a chair and sent it back. That is the history that we can derive from this state. Now, if we use event sourcing, it's slightly different. Instead of storing the state, we store everything that happened to that order in the past. So we see an order has been created, but now we can see 2 items were added, and then 1 was removed. That's information. That's information that we did not have in the state storage. Then the order was confirmed, it was shipped, it was cancelled, and then we waited for the return shipment. And there's information in here, and you might have means to either prevent somebody from buying something he doesn't want, or I don't know what you could do. I'm not a retail expert, but it's obvious that there is some information in here. But of course, our application doesn't really work with history, right? We don't really care. We don't want to have this additional complexity in our application. Any decisions that we make should be based on the current state. So what we do is we have an empty order, and we replay all of these events on it, changing its state accordingly. And the resulting object after the end of the stream, that is the current state. That is what we want to work with. And of course, you can build everything for yourself. Trust me, because I did. And it's a lot of fun, and especially a lot of fun if you want to maintain it. There's a couple of lessons learned from this experience of CQRS, especially nowadays with the, if I may call it so, hype of microservices. Right? There's a lot of people are moving towards microservices, and they do so in different ways. And what we have learned is that the monolith is not such a bad thing. And there's a very big difference between a monolith and the big ball of mud, let's say. For one, the monolith doesn't smell. Right? For the other one is, I generally believe that if you were assigned the task to break the thing apart, that you would definitely prefer to work on the monolith, especially if you have to use your bare hands. So breaking a monolith apart can be difficult, but it could also be easy. Now, Martin Fowler did an observation of monoliths and microservices, and I don't know how many projects he has seen on which he based this observation. I have seen a few, and I can confirm that in those situations, I've seen a few microservices projects that went from the ground up. They started as a microservices project, and they failed. And as I said earlier, failure is good, because it's a learning experience. However, a multi-million euro learning experience is maybe not the best way to do. So if you want to learn fast and learn cheap, right? Or if you want to fail fast and fail cheap. And the reason for this is microservices is really hard, right? There's a lot of things that you need to care about that maybe you don't really want to care about. And of course, there's a lot of solutions, there's a lot of tools out there, but still it means you have to learn how to use these tools. And but probably the most difficult thing about microservices is, where do we cut? What do we put in one service and what do we put in another? And that is something that probably needs to evolve. You need to start understanding your domain, find out where these bounded contexts are. You definitely do not want a single service living in more than one bounded context. But even within that context, there's a lot of places where you can make cuts. So this is our symbol for a business case, right? You have an idea of something that makes money. It's as simple as that. A business case is a function, right? You put something in and there's money coming out, then it's a good one. And our goal is, let's use microservices for this. Now this road, as I said, is a difficult one, and many of us don't survive it. Because you don't really end up, well, you end up either like that, whatever it was, or you end up with the distributed big balls of mud. Yes, it's definitely worse than the single one, right? So the distributed monolith is basically, well, that's basically that. It's not completely fair because the term monolith is not really used correctly. So what we believe instead is creating a structured monolith. So have a monolith. Why not deploy everything in an application, in a single boot application? That's fine, but at least make sure that there's some structure inside of it. Make sure that there are some seams that you can use to cut it into pieces. And as time evolves and you find out, okay, what is an important thing to deploy separately now? And it might be that blue component, and it might be for whatever reason. I mean, I've heard reasons like, oh, the team is growing too large, we need to split the teams because we're working on the same Git repository, it doesn't work anymore. And that's fine. I've heard reasons like the deployment cycle of this blue thing is different, or the stability requirements of this blue thing is different. Like it's crashing all the time, and we don't want it to cause a crash of the rest of it. Okay, maybe you want to resolve the crash, but if you can't, isolate it. Right? Deploy it separately. Just let it crash, but make sure it doesn't crash the rest of it. And as time evolves, you can deploy or extract more of these components and maybe even scale them up. You can start scaling them separately as well. And while we're at it, why stop at microservices? Why not go all the way serverless? I don't care how many instances I've got running. Just have it running. And if I need more, make sure I get more. I don't really care. We should stop caring. And the aspects that makes this all possible is the concept of location transparency. So when two components communicate, they should not be aware of their respective locations. So when one component has some communication with another, it should not know where the other one is. Is it in the same JVM? Is it deployed somewhere else? And preferably, it doesn't even know to which component it is communicating. So preferably, it would just say, I've got a command that needs to be executed. System, make sure it happens. Route it to whatever component that can actually do that for me and give me back an OK or whatever you want back. And the same for queries. This is a little architectural diagram before we dive into code. On the left, we have the UI, and you can see there's some commands going to some command handling component. That's great. That command handling component uses a domain model to validate the commands and also to decide what should happen. And whatever comes out of that decision is another number of events that are published to these event handling components. And that event handling component probably updates some other domain models, in our case, projections. And the UI can then query those new projections after the command was executed. That's in theory. So by putting some buses, we call them command bus, an event bus, and guess what, query bus over here, we provide this location transparency in Axon. So the UI puts a command on the command bus. It doesn't know and it doesn't care where that command is routed, other than it knows it will be routed to some place that has indicated it can handle that command. Right? Same for events. When you publish an event, you're not publishing an event to a component. An event is a description of something that happened, and whoever wants to take it and whoever wants to do something with it can do so. And these location transparency boundaries, they are over here. So basically, you can decide to have command components deployed separately from the query components. You can, it doesn't mean you must, right? But if it makes sense in your particular environment, if the non-functional say it's necessary, then you can do so. All right, so that's all very nice, all very theoretical. Let's see what that looks like in action. So we have this sample application, and you can check this out on GitHub as well. On the Axonic GitHub, there's the gift card application. It's a very simple application. We might as well run it to see what happens. Now, while it's starting, Let's have a look at the gift card. So this is our command model, and it's a fairly simple model. We took this on purpose. Maybe it's not the best business case of CQRS, although it is a somewhat pseudo-financial one, I guess. But it's more to just to have a simple showcase. So this particular aggregate is event sourced. And the way you can see that is there's two types of methods on it. There's, whoops, oh, come on. There's command handlers on top there, and these command handlers only make decisions. They do not change any state. So you can see if the amount is less than 0, then I'm going to reject it, because you cannot issue a gift card that has a negative amount on it. Makes sense. And then it just applies it. Well, that's not really very interesting. It applies an issued event. But if we look at the handle redeem command, the second method over here, you can see here that we are going to check, okay, if you want to redeem a gift card, basically take money off the gift card, but you're trying to take more money off than is actually on it, we're going to refuse that command. Right? We're going to throw the very nice illegal state exception, which I guess we all love. It's a beautiful API. And if it passes that test, we will apply a new redeemed event. Right? So there's no state changes involved, and that's very important when doing event sourcing. Now, on the bottom there, we see an event sourcing handler that says, oh, if a gift card was issued, when this gift card was issued, we should change the state. So we set the identifier of the gift card, and we set the remaining value to the amount that it was issued for. And when a gift card was redeemed, what we do is we take off whatever amount it was redeemed for, and we subtract that from the remaining value. Now, there's no validation in here, because in these events, we are dealing with things that happened in the past. And you can dislike things that happened in your past, but let's be fair, that's going to be your problem, right? It happened, so deal with it. You can either ignore it, if you want to, or deal with it, but there's no denying it. Now, this separation is important because when we load the aggregate from the repository, we want to apply all these state changes that we have decided should happen in the past so that we can reconstruct the current state. So Axon will make sure that this aggregate is correctly initialized, and then that the command handler method is invoked. Now there's a little annotation on top here, the @aggregate one, and this secretly makes your aggregate a prototype scoped bean for Spring. Don't tell anyone. And that's not really important. We don't really care about it. We care that this is an aggregate. And there's a Spring Boot starter for Axon that automatically detects these aggregates. It will automatically detect beans with event handlers on them. And we'll have a look at those in a second. And it will make sure that they are connected to the appropriate bus. So when you send a message to the command bus, it will end up in the gift card. Now we have another bean. This is just a regular Spring add component. Forget the processing group for a second. And it has event handlers on it. And this means when a card was issued at a particular time, then we are persisting a card summary. And basically that is our view model. It's a summary of the gift card, and it has an ID, and it has the amount as well as the timestamp on which it was issued. Right? Now note that this timestamp is not important in the gift card itself. There's nothing in this gift card here that has any validation on the issue date yet. Probably in real life you would say it's only valid for a year or whatever. But in this case, we don't care about it, so we don't need to model it. And anything that you don't have to put in your model makes your life easier. And then there's some query handlers that say, well, if you have this particular questions, if you want to find some card summaries, okay, we're going to map that to a query. In this case, we're using Entity Manager. It might be a Spring JPA or a Spring repository whatsoever. That doesn't really matter. There's also account cards, and this has to do with the UI that we chose, which is a Vaadin UI. Not because we love Vaadin, but because it's really easy. We are back-end guys, so we need something back-endish to build a front end. And then this is what you get in reality. So there's already some data apparently in here, but what I can do now is I can issue a specific card. I give it 1, 2, 3, 4. Hope that one didn't exist yet. And let's put 1,000. Yes. Yeah, there it is. So 1, 2, 3, 4 is there with 1,000. And everything is running as a monolith. And that's really nice and that's really easy, right? We like monoliths because we can click start and then the whole thing runs and it all works. Maybe it eats a bit of memory, but who cares? And we can redeem that. We can say take it and then redeem it for 10 euros. And we see the remaining value on the right decrease. So as the UI is triggered to do the query again, the information is updated. So this is really nice, but everything runs in a single VM, and I made this promise about location transparency, blah blah. So let's scale. So a friend of mine, he says, no matter what your problem is, start.spring.io. So we want to scale this. So what do? We go to start.spring.io. Let me quickly grab a cheat sheet because I know everything will go wrong. Everything that can go wrong will. So I want to minimize that. So let's create a gift card. So what we want to do, first mistake, what we want to do is scale this application, and since this is a Spring conference, we want to use as many Spring components as we can, or as we need, basically, to scale this out. So what we're going to do is use Spring Cloud Discovery to discover nodes, so that Axon knows where to send a command. Which other candidates applications do we have out there? And we are going to use RabbitMQ to publish the events. Why? I guess because we can. So let's do some discovery stuff. Discovery Eureka server. I think that is all we need. And we'll have another one for the command module, which does not need discovery. We need web, we need JPA, we need H2. A Rabbit client. Unfortunately, Axon is not yet part of the initializer. All right, and let's unzip those. Oops, downloads. All right. Now we need to include them in IntelliJ, so they're proper, separate components. Oops. Oh, I love this. That's great. What was that thing about anything that can go wrong will? JetBrains people, why doesn't it allow me to open my POM? Yes, it's all there. There you go. That one works. That one doesn't. That's beautiful. Okay, let's do the Windows thing. Restarting always works, except when you're in a demo. Yes. Okay, let's all watch the bar, the progress bar. That's interesting. Okay, here we go. Oh, scanning files to index, that's usually good news. All right. Ah, there is a Maven project, discovery. That's interesting. But it's not there. See? Rebooting works. That's why I love Windows. You've got a simple solution to all of your problems. All right, so we have our discovery, and we need to do a few things here. So in our application, we have to enable discovery, Eureka, server. Make sure you don't put in client like the other day. And we need a few properties just to make sure Eureka doesn't complain about everything that we do. It was on the internet, so I just copy-pasted everything, and it works. All right, so that's our discovery. So what we want to tell it, that it runs on port 8761, apparently the default port. And so now we have this this empty application for gift cards. I'm doing a little bit of renaming. Oops. To make my life easier in a second. And I can create a package, command. So what I'm going to do is literally what you would do in practice, and take a component out of your monolith and moving it to another jar. That should work. What can possibly go wrong? So what we're going to do is move this gift card to another source, which in our case is the command source. We're going to refactor. It's going to complain because it cannot find certain classes. That's fine. So we move this to the other jar, and it's gone from the bottom one. Now what we also need is, and that's why we had these warnings. So the gift card API depends on a number of classes, mainly the commands and events. And we like Kotlin to express these commands and events because you can have a single file and put every command or event on a single line of code. If you do that in Java, you'll have a class or a file per class, which is, well, not fun. And let's move this file to the API. There we go. And I'm going to take, and this is, of course, very good practice. You just copy all of your classes, right, and move them somewhere else. Kotlin not configured. There we go. Okay. Now it complains about not finding Axon, and as I said, unfortunately Axon is not yet part of the Spring Boot initializer, so there's an Axon Spring Boot starter. 3.2.2. And basically this is a typical Spring Boot starter. It will inspect a lot of things, do a lot of magic or auto configuration, whatever you want to call it, and it magically makes sure everything works. Now we are going to use the discovery client to send commands. So we are going to use the Axon distributed command bus Spring Cloud version 3.2.2. So this is the command bus that knows about the distribution of the system among different nodes and uses Spring Cloud to discover these nodes. And as I know that we're going to use AMQP as well, AMQP, going to, to use that as well. Now in my UI, I already prepared these dependencies to make it slightly faster. like that. So these are the same dependencies. So some of these, like the Spring Cloud Starter Netflix Eureka client, you have to catch your breath after that name. That is one that you would automatically get if you select it on the Spring Initializer. There's a few things I need again in my application. I need to enable Eureka client. Is there anything else I need? Yes. Eureka likes an application name, which is gift card UI. That's fine. And just the mere fact of having some discovery client and saying, hey, I want a distributed command bus in the POMs is not enough for Axon to say, well, let's do all the magic for you. So you have to say distributed enabled is true. Yes, I do really intend to make this a distributed application. Otherwise, a lot of stuff would happen that you do not like. And for our command, it's the same thing. Let's go to application properties. There's a couple of properties I'm going to copy paste into here. Note the application instance ID. That's because I'm running on port 0, and Eureka uses the port to uniquely identify nodes or instances. And port 0 basically means just grab whatever you like. And instead of taking the actual port that was assigned to it, it takes 0. And if you have instances with the same ID, Eureka does really nice things. Basically, it replaces one with the other. There's also a configuration line saying axon.amqp.exchanges events. And this will publish all of the events that you're publishing on the event bus to this particular exchange in RabbitMQ. The only thing we need is telling Spring to declare that exchange. This is just Spring code. So we declare an exchange, and then we use AMQP admin, again the Spring AMQP thing, to actually declare it when this application starts up. Now we can import these, and we should be all right to start this application. So we can start the discovery application. We are good to start the command application as well. Now this is going to be tricky. There's not much time, and there's drinks. So this better just work. And if it doesn't, somebody go grab a few beers and then come back, and we'll get it to work. Okay, a few imports. It's almost compiling. Starting to feel like a Friday afternoon deployment to production. Okay. By your reaction, I get this feeling that you've been there. It's scary. I think I forgot my, yes, enable Eureka clients, discovery clients. There we go. Stop. Start again. Right. Anything else I forgot? I hope not. And let's start the UI in a second. So our UI at this moment, the application, it does no longer have the command model, right? So any commands that it will try to dispatch internally, it will not find a handler for, because it's just not physically deployed in that jar. And so I hope. Every now and then there's some file system cache lingering around, and it can actually find the class files still. So let's see what happens. So it seems that these applications have started. I can go to my Eureka dashboards, and I see a command module being up. And any moment now I should see the UI coming up, and I should be able to refresh this, and it still works. Okay? This is the scary part. So now we're going to send the command, and it's success. So right now what it's doing is it's transferring this command to another node and it's executing it. Although I do think, well, let's choose 0000. It's successful, but we're not seeing it in the view. Now why is that? Because we have an exchange and we're publishing events, but we haven't told the UI to actually take these events off and start processing them. There's an event handler waiting for events, but it's connected to more or less dev null at the moment. So what we need to do is in our UI application, again, have a lot of interesting Spring AMQP configuration. So we are declaring a lot of stuff in here. So we have an exchange, we have a queue, and then we have a binding to bind the exchange to the queue. So the exchange is what you publish to, the queue is what you read off of, and then the binding says if somebody publishes to that exchange, I want those messages to be queued over there. And now we need to tell Axon that we want to have a particular source of messages that is taking events off of a queue on Rabbit. Subscribable message source. Doesn't matter. And we want a Spring AMQP message source. It requires a message converter. So the message converter decides on how do I convert an Axon message to a RabbitMQ message. So you can configure a lot of stuff here. And I'm going to do a little trick because Spring has very nice annotations to react to invoke methods. So what I can do is make this a Rabbit listener that listens to a specific queue called events. Now if a message arrives on that particular queue, Spring will invoke the onMessage method, which will then be picked up by this Spring AMQP message source that transforms it into a Axon message. And we want to make this transactional, make sure I get the right one here. Like so, and we take this bean. And now we need to say that the event handler called, what did we call it? UI query has a particular source, which is the events queue. So now this says that that particular event handler that we've built, it should take messages from this source, which is the source that takes the messages off of Rabbit. Now let's see what happens if we restart, stop and rerun. Oh, we didn't do a clean stop. That's always nice. Eureka loves that. Yeah, I knew it. Pushing my luck. Okay. Some generics missing, pretty sure. That's one of these uh-oh moments. Uh-oh. What do you want? I failed to instantiate circular reference. Ah, binding. Ooh, thank you. I think, wait. Yes, okay. Using the same B name in different places is not recommended. Not in a Friday afternoon deployment when you've got 2 minutes before beer. But 2 minutes is all I need, hopefully. This is going to be a long night. Right, so that works. Yeah, blah, blah. I mean, it's red, all caps, bold, probably not important. Amount, 1, 2, 3, 4. Let's submit this, see what happens. Hooray, we've got it. With 1 minute 30 on the clock. That's it. Let's go back to this. There's one more slide. It has my Twitter handle in case you have any questions. The easiest way to contact me is straight to my face. But if you cannot, for whatever reason, distance being one of the reasons, manage, I am available on Twitter. And maybe we can take one question. So only the one person that has this really good question. Oh, that didn't work, did it? All right. If you have any questions, come up. We'll have a beer and discuss whatever you want. Thank you.